Last time we talked about how to graph quadratics in standard form. Today we're going to learn vertex form and intercept form. And you'll find why we call those vertex form and intercept form. It give you a hint. It has to do with their names. So let's start by taking a look in Desmos and see if we can figure out those connections. So feel free to play around with this in Desmos. You have the link in Classroom or on the website. So for vertex form is y equals a times the quantity x minus h squared plus k. So in this format, as I move these values around a, just like in standard form, we know what a does. It deals with the shape of the parabola, whether it opens up or down, narrow or wide. So the way that we can get an equation from standard to vertex form is if we were to complete the square. So if you take the equation and complete the square, that'll put it into vertex form. I won't go through that now, but if you're interested, I can show you another time. So once it's in this form, it's helpful because, well, look what happens when x changes. It's negative, it goes left. Positive shifts the graph right. And the k value, it's positive, it shifts up. Negative, it translates down. And let's say my h is 5, my k is 5. Notice that point is highlighted right here. So h and k are the coordinates for our vertex. So if h is negative 1 and k is 2, I know my vertex is 2, or 1, negative 1, 2, rather. So it's a way that we can find that vertex very quickly and easily, just based off of what we have. So x, so in this case, our function is y equals 2 times the quantity x minus, well, h is negative 1, so it's actually x plus 1 squared plus 2. And so I see x minus a negative 1, and this is plus 2. And then I can figure out my vertex and my axis of symmetry very quickly. And then all it is a matter of putting in points. So if I wanted to find my intercept, I would just substitute 0 in for x. 0 into x here. So 0 plus 1 is 1. Square it, it's 1. Times 2 is 2. 2 is 4. And so that would give us our intercept at 0, 4. And we could just reflect it across to find another point and graph it from there. So notice it's called vertex form, well, for that manner that you can find the vertex very efficiently. You have this in your notes. We talked about that already. So I'd like you to take the time to graph this function. See if you can find its vertex, axis of symmetry, and perhaps find the y-intercept and graph the parabola. Restart the video when you're ready to check it out. So I know the a value is negative 1, so I know it's going to open down. The vertex is negative 2, 3 because x minus a negative 2. And if you can't remember that, think, well, what's going to give me 0 here? Because if this is 0, when I square it, it's nothing. Multiplied, it's still nothing. Plus whatever I have. That's going to give me my maximum or minimum when this is 0. So make this 0. So negative 2 plus 2 is 0. So my x is negative 2. And my k, my h and k, is going to be 3. It means the axis of symmetry is x equals negative 2. And then to find a convenient point, I can find that y-intercept. Plug 0 in. 0 plus 2 is 2. Squared, it's 4. Multiplied by negative 1 is negative 4. Add 3 is negative 1. So I plot 0, negative 1. Count 2 spaces, so 2 spaces across, or 2 units rather. And I know I have another point at negative 4, negative 1. 3 points are all I need for a parabola. All right, so let's take a look at how we can convert this one into vertex form using the complete the square method. So remember, if I want to complete the square, I want to kick out this 11 because I don't need it for now. So y minus 11 equals x squared minus 8x plus my c value. So what's my c value going to be? Well, remember it's half the b, and then square it. So negative 4 squared is 16. So if I add 16 to both sides now, I can complete my square. So I'll have y plus 5 on the left, and my perfect square trinomial will be x minus 4 squared. And then all I have to do is bring this 5 back over. So subtract it, and I end up with y equals x minus 4 squared minus 5. Now it's in vertex form. If you prefer standard form, work with it, that's fine. Here's how to convert it to vertex form. So now I know my vertex has to be, well, what would it be? HK. So vertex will be 4, negative 5. Because 4 minus 4 is 0. So 4, negative 5 means my axis of symmetry goes x equals 4. Now all I got to do is find my y-intercept. Well, my y-intercept, I can look back at my standard form equation, is 11. That's way up here. So if I don't want to use that point, if it's not convenient for the graph that I have right now, I know that I can just choose a different point. What's another convenient point? Well, if my axis of symmetry is 4, I can choose one to the right or one to the left. So let's just put 5 in. 5 minus 4 is, so here's my points, 4, negative 5. Sorry. So if I plug 5 in, go back to that. 5 minus 4 is 1. Squared, it's 1. 1 minus 5 is negative 4. So 5, negative 4. Reflect it. There we go. So since my vertex was a little bit further away from that, from the origin, my y-intercept is going to be a little bit higher, so I can choose different values. Okay, so that's how we can change it from standard to vertex form in order to find that convenient point. If you like doing the negative b over 2a to find your axis of symmetry, maybe you keep it in standard form. So finally, we'll take a look at what's known as intercept form. Let's go back to Desmos and see what that does. So intercept form is y equals a times the quantity x minus p times the quantity x minus q. So this is a quadratic still because we separated the x's. X times x is x squared. This would be in factored form. Okay, remember all that factoring we did? Here's what it looks like when we graph it now. So notice a value, same as before, does the same things. Let's keep it at 1. Now the p-value. Notice what happens when I change the p-value and the q-value. And what are those? Those stay on the x-axis. So those are the x-intercepts. P and q stand for the x-intercepts. Notice that they also, we also call those the roots of the equation, the zeros, and in this particular form we can find, did I mention called the x-intercepts? So that's why it's called intercept form. We can find the intercepts very quickly. So if it's like this, so in this case, this would be the function y equals a, so that's 1, and it's just x minus p, so x plus 4, and x minus 2. Notice if I were to solve these, what's when y equals 0? This is just solving the quadratic equation in factored form. So I would say, oh, x plus 4 equals 0, or x minus 2 equals 0. And so I know, okay, x equals negative 4, or x equals 2. So 2, 0, or negative 4, 0 are the 2 points that I'm looking at. And look at that, that's where they are. And notice, any 2 points will be reflected, how do we find that axis of symmetry? Well, I know these 2 points, if they're equal distance apart, these are 6 units apart, I know the axis of symmetry should be halfway between there. So 1, 2, 3 units will give us our axis of symmetry. So I know that my axis of symmetry would be Well, halfway between negative 4 and 2. And that would have to be at negative 1. So my axis of symmetry would be at negative 1. And how would I find the vertex point? Well, I just plug negative 1 into the equation. And that's how I could find that. So we'll work with that in a couple examples, but I want to show how that works, how we use those, how we use this form of the equation to help us, and how factoring would help us in this case. So once again, you have this in your notes. Take note of those key points, how to find those intercepts, and the axis of symmetry is going to be halfway between there, between these two intercepts. That's how we can easily find that. So let's start off with this one. So if I'm going to graph this one in intercept form, I see it's factored. So I want to know, well, when y equals 0, what are my x values going to be? Well, in this case, I would say, well, x plus 1 would equal 0, or x minus 5 equals 0. And so I would know that x would be negative 1, or x would equal 5. So that gives me my x-intercepts, 5 and negative 1. I know my axis of symmetry is going to be halfway between. So what's halfway between 5 and negative 1? Well, if you can't tell, look on your graph. 1, 2, 3, 4, 5, 6 units, so halfway 1, 2, 3. Right here at 2. The other way to figure that is find the average of these. 5 plus negative 1 is 4. Divided by 2 is 2. So my axis of symmetry is 2. How do I find my vertex? Well, I plug 2 in because the vertex is located on this line when x is 2. So I put 2 in. So I say y equals negative 2 plus 1 times 2 minus 5. So what do I get for my y value? Y will equal negative 1 times 3 times negative 3, which will be, what, positive 9? So 2, 9. Plot that point on my graph, and there we go. Boy, that was terrible. Let's try that again. Well, I hope you're better at drawing parabolas than I am, but is that right? Should it open down? Yeah, see we got a negative there. So since our a value is negative, this should open down. All right, this is in standard form. Let's say we wanted to change it into intercept form to help us find our intercepts very quickly. Well, I see I've got a GCF of 2. So let's factor out the 2, and we're left with x squared minus 4. 2 terms, so let's factor it down, difference of perfect squares. So it'd be x plus 2 times x minus 2. At this point, I see my x-intercepts, and maybe you can pick them out, but I would see that my x-intercepts would have to be negative 2, 0, and 2, 0. Because those are the values of x that make these terms 0, which would end up making our y value 0. So negative 2, 0, and 2, 0. And I can see that my axis of symmetry here is x equals 0. So if I plug 0 into my equation, 0 squared is 0 times 2 is 0, minus 8 is negative 8. So my vertex would be 0, negative 8. And that's how we can get it from standard to intercept form in order to find some points pretty efficiently. All right, so today we learned vertex form, help us find the vertex, and intercept form. So right here we're just going to rehash all these 3 different forms that we learned and pick out the ways that we can pick out some of that information very quickly. So If you want, you can pause the video here and see how we find that information and see what is recorded there, and restart it when you're ready to see the information. So take the time to look at and analyze the different forms of the graph or forms of the equation. So this first one is vertex form. We can tell by this one that it opens up since it's positive a value, and it's a 3, so it's narrower since its absolute value is greater than 1. You can find the vertex for 3. Remember that vertex is HK in that format. And we can find the y-intercept by plugging 0 in for x, and we get 51. The x-intercept are difficult to come up with in this one because there aren't any. In this case, you'd have to substitute 0 in for y and solve for x. You'd find that you can't do that. It has a minimum value since it goes up, and that value is 3. Its axis of symmetry would be 4. Its domain is all real numbers. And I guess I didn't fill in the range. The range would have to be all y values greater or equal to 3, that minimum value. Everything's above 3 for that one. The next one's in standard form. Standard form, you see it opens up because the a value is 1. It'd be the same since its a value is 1. In order to find the vertex, we got to find its axis of symmetry, which is negative b over 2a in the standard form. So positive 2 divided by 2 times 1 gives us 1. Plug 1 in to find our vertex. In order to find the y-intercept, we can plug 0 in for x. X-intercepts, we could factor that into intercept form. So we could get x minus 3 times x plus 1. And see that our intercepts would have to be 3 or negative 1. The minimum value is with the vertex, negative 4. Domain is all real numbers, and the range would be everything greater than or equal to negative 4, that minimum value. And then the intercept form, we know it opens up since the a value is positive 3, so it's going to be narrower. Vertex we could find after we find the x-intercepts. X-intercepts are 1 and 5. And so the vertex will be halfway in between there. Our axis of symmetry will be 3, halfway between 1 and 5. Plug 3 in, and we get our vertex. Our y-intercept we can find by plugging 0 in. And our minimum value goes along with our vertex. Domain is all real numbers, and our range is greater or equal to negative 12. If the graph opened down, our range would be all values less than that maximum. So some forms of the equation give us information a little bit quicker, like the intercepts. We can find the intercepts very quickly. And then the axis of symmetry is halfway between there. Standard form, we can find our axis of symmetry and our intercept rather quickly. Intercept's the c value. Vertex form is, we can find that vertex and go from there. So all are different forms and different things you can find a little bit easier, but all beneficial. We can switch back and forth between some of the others, so practice using those in your work. We'll talk more about next time about modeling using quadratic functions.